Section 2, question 3. Triangle ABC is right angled A and BD is a bisector of angle ABC, because that angle in the middle is denoted by x and x. AB is 6 units and BC is 10 units. Determine the exact value of BD, expressing your answer in the simplest form. Well, a bit of Pythagoras, and I would show my working for that, will tell me that that side is 8. So this side squared is equal to 10 squared take away 6 squared. Square root of 64, and that's 8. But I'll show you a bit of working for that at the side. Determine your exact value of BD. Right, so the first thing that I would have a go, just a wee bit of experimentation, is to say that x and x can be written as 2x. So I could say that cos 2x is equal to adjacent over hypotenuse, 6 over 10. And that could come down to 3/5. Now in terms of it as to why I've made that step, just a wee bit of experience with these questions just tells you to try and make a bit of forward progress by putting something down. So cos 2x equals cos of the angle, which 2x is equal to adjacent over the hypotenuse, which can be simplified 6 over 10 down to 3/5. I'm now going to apply my double angle formula, one of them, and I'm going to choose another one, but I'm going to choose 2 cos squared x minus 1 is equal to 3/5. Then get 2 cos squared x is equal to 3/5. Bring minus 1 across, make it plus 1, that's plus 5/5. So I've now got 2 cos squared x is equal to 8/5. So cos squared x will be equal to 8/5 divided by 2, which is 4/5. And cos x will be equal to the square root of 4/5, which is 2 over root 5. Square root on top and bottom. Now that's telling me that the adjacent is 2 when the hypotenuse is root 5. But I need to scale this up because the adjacent is actually 6. So that's 3 times 2. Now if that's the case, to keep the ratio in the triangle equal, I would also need to multiply root 5 by 3, and that would give me 3 root 5 for the length of dB. And that's the end of the question. Section 2, question 4. Express 5 sin x minus 12 cos x in the form k sin x minus a. K is greater than 0 and the angle lies between 0 and 360. So it's going to be 5 sin x minus 12 cos x is equal to k, rectangular bracket. The sine minus expansion is sin cos minus cos sin. So 5 sin x minus 12 cos x is equal to, I'm just going to flip these round as I bring them out. So it's going to be k cos a sin x minus k sin a cos x. So now I can see that the coefficient of sin x is 5 and the coefficient of sin x is k cos a. Therefore k cos a is equal to 5. Coefficient of cos x is minus 12. The coefficient of cos x is minus k sin a. Therefore minus k sin a is equal to minus 12. I'm just going to quickly say that there can cancel the negatives, and k sine A will be equal to 12. So I've got k sine A over k cos A is equal to 12 over 5. K over k goes. It's just around about this point that I'm deciding which quadrant I'm going to lie in. So it's going to be the all quadrant and the sine quadrant. For sine, for cos, it's all in cos, 2 ticks in all quadrant, and that's where I am. So sine over cos is tan, so I've got tan A is equal to 12 over 5. That's a calculator question, so enter that into the calculator. A is equal to tan inverse 12 over 5. We're in degrees, and to 1 decimal place, that's 67.4 degrees. I'm going to find the value of k, so that's the square root of 12 squared plus 5 squared. Square root of 144 plus 25. That's square root of 169, and that's equal to 13. So my wave function then is, I have to write it in the form k sine x minus a. So pretty straightforward at this point. And that will be 13 sine x minus 67.4, and that's part A. Part B says, hence solve the equation 5 sine x minus 12 cos x is equal to 6.5. So hence means 5 sine x minus 12 cos x. I now use the fact that I've written that as one trigonometric expression, 13 sine x minus 67.4, and I make that equal to 6.5. So the first thing to get going that I'm going to do is to adjust my limits by taking away 67.4. So my new limits will be minus 67.4, and the upper limit will now be 360, take away that, and that's 292.6. Okay, so I'm ready to start proceeding with the question. So sine of x minus 67.4 is equal to 6.5 divided by 13. So that cancels quite nicely. That's sine of x minus 67.4 is equal to 1/2. Round about just now, I'm putting the 4 quadrants down, and I'm lying in the all quadrant and the sine quadrant. So x minus 67.4 is equal to sine inverse 1/2. This came up in the calculator paper, but this particular bit should be able to be completed without a calculator. So x minus 67.4 is equal to sine inverse of 1/2 is 30 degrees. So that's my all quadrant solution, and the sine quadrant is going to be 180. Take away 30 degrees, and that's 150 degrees. I then need to bring minus 67.4 across and add. So first solution is going to be 97.4 degrees, and my second solution is going to be 217.4 degrees. Now if I move backwards or forwards by 360 degrees, because that's how often the sine and the cosine curve repeats, I could do a quick double check of that, but that will bring me out with my limits, and I should have checked it up there. But it would have brought me out with my limits, therefore there's no more solutions, and that's the question done.